This is a problem about work. Reggie and Rima work together to mulch the flower beds around an office complex in 2 6/7 hours. Working alone, it would take Reggie 6 hours more than it would take Rima. How long would it take each of them to complete the landscaping working alone? Well, let's think about this. We need to familiarize ourselves with the problem. We are told that Reggie will take 6 hours more than Rima to do the job. So let's let R be the time that Rima takes to do the job. Let's let R equal Rima's time. And these times are in hours. And we're told that Reggie will take 6 hours longer than Rima. So 6 more than R, or R plus 6, is going to be Reggie's time. Now, and we're also told that it takes 2 6/7 hours working together. So let's see if we can translate to an equation. We know that we have a work principle that says that T over A plus T over B is equal to 1, where T is the time required to do a job when 2 people or 2 machines work together, and A is each of the individual times. Now, this is a little different from some of the problems that you might be used to doing, so if you see something like this on a test, just stop and think about it a minute before you start substituting into this work principle equation. What we are given here is the time together. A lot of times we're asked to find how much time it takes 2 people working together to do a job. Here we're given the time it takes together, and we're asked to find their individual times. So in this work principle, we're going to substitute 2 6/7 hours for T, and let's write that as a fraction as 20 over 7 hours. So I'm going to substitute 20 over 7 for T in each place. And A and B are the individual times, and Rima's individual time is R, and Reggie's individual time is R plus 6. So I have the equation 20 over 7 over R plus 20 over 7 over R plus 6 equals 1, and this is the equation then that we need to solve. So let's go to that step of the process. This is the equation, and I'm going to simplify each of these complex fractions. 20/7 divided by R is the same as 20 over 7 times 1 over R, and this is equivalent to 20 over 7 times 1 over R plus 6, and that's equal to 1. Now I'm just going to do the multiplications on the left-hand side. I'd have 20 over 7R plus 20 over 7 times the quantity R plus 6 is equal to 1. And I'm going to multiply by the least common multiple of the denominators to clear the fractions. And that least common multiple is, I'll have a factor of 7, and I'll have a factor of R, and I'll have a factor of R plus 6. So 7R times R plus 6. And this is what I'll use to multiply on both sides of the equation. So on the left, I'll have 7R times R plus 6 times the whole left-hand side of the equation. And on the right side, I have 7R times R plus 6 times 1. And we're going to need a little more space. This is the multiplication that we just did to clear the fractions from the equation. And removing parentheses on the left-hand side, I'll have 7R times R plus 6 times 20 over 7R, this quantity times this first term. And then we'll multiply it times the second term as well, times 20 over 7 times the quantity R plus 6. And on the right-hand side, let's just keep this as a product for now. Now on the left-hand side, when I do this multiplication, the 7R's cancel, and I have 20 times R plus 6. And in this multiplication, the 7's cancel, and so do the r plus 6's, so I'm left with r times 20, or 20r. And I still have 7r times r plus 6. And now let's go ahead and do these multiplications. 20 times the quantity r plus 6 is 20r plus 120, and then I have plus 20r here. And doing this multiplication, I get 7r squared plus 42r. We can collect like terms on the left-hand side. 20r plus 20r is 40r plus 120 is equal to 7r squared plus 42r. And let's just go to a new piece of paper so we have time, or have space to finish this. We have 40r plus 120 equals 7r squared plus 42r. We've got a quadratic equation, so we would like to get all of the terms set equal to 0. And I can do that by subtracting 40r and 120 on both sides. And I get 0 equals 7r squared plus 2r minus 120. Now let's see if we can factor the right-hand side. We can factor it as 7r plus 30 times r minus 4. And now we can use the principle of zero products. We could say that 7r plus 30 is equal to 0, or r minus 4 is equal to 0. And let's work with this first equation. 7r plus 30 equals 0. I can subtract 30 on both sides, and then I can divide both sides by 7. So I get r equals negative 30 over 7, or on this side, on this equation, I can add 4 on both sides. So I get r equals 4 here. Now, we need to check these possible solutions in the original problem to see if they are solutions of the original problem. We had r equals negative 30 over 7 and r equals 4. Now, since r is a time, a rate of work, it cannot be a negative number. It's a solution of the equation that we wrote, but it is not a solution of the problem that we're solving, so we don't need to check this. But let's check r equals 4. Remember that 4 is, r is Rima's time, so if r is 4, then r plus 6 is 4 plus 6, or 10, and this would be Reggie's time. So we're saying Rima's time is 4 hours, and Reggie's time is 10 hours. And let's see if that makes sense. In 27th hours, Rima does 27ths over 4 of the job. That's the fraction of the job she does. And Reggie does 27ths over 10 of the job. And we want to see if this is equal to 1 complete job. So we have 27ths times 1/4, simplifying this, plus 20 over 7 times 1/10. 20 over 7 times 1/4 is 5 over 7. And 20 over 7 times 1/10 is 2 over 7. And 5/7 plus 2/7 is equal to 1. So this tells us that if Rima does the job alone in 4 hours and Reggie does the job alone in 10 hours, then in 27th hours they would do 1 complete job. So we know that we have a check to the exercise. And we can just state the answer now. Working alone, it would take Rima 4 hours to do the job, and it would take Reggie 10 hours.